If you want to introduce caching to your .NET applications, there is one library that you should know about, and it's called FusionCache. In this video, I'm going to give you a general introduction into the FusionCache ecosystem and what it can do for your .NET applications. First of all, what is FusionCache? It's an open source and easy to use caching library, and it's built by Jody Donetti, who I've had a chance to meet at the Microsoft MVP Summit last year, and I can tell you he's an awesome guy building a very cool library. Now, what makes it stand out is first of all the functionality and the performance that it offers, but also the extensiveness of the documentation. I mean, just look at the diagrams here, absolutely beautiful. It comes with two-level caching with an in-memory and a distributed cache. It also has a backplane for synchronizing the cache between multiple application servers, and the documentation is just great. You get everything you need to get started. There's docs on the dependency injection support, there's docs on the level 1 and level 2 caching, there's documentation on the backplane and how it works to synchronize your distributed cache between multiple services, and there's docs on the hybrid cache support, which I'm going to talk in the end. And a fun piece of information is that FusionCache is currently the only production-ready implementation of the hybrid cache abstraction. So enough about the intro. Let's see how we can introduce FusionCache to our applications. I'll start by installing the core library inside of my application layer, and I'm going to look for FusionCache. And I know somebody's going to ask this in the comments. No, this video is not sponsored by FusionCache. I'm just making it for the love of the game. So what I'm going to install inside of my application layer is the Ziggy Creatures FusionCache library. This will give me access to the core abstraction, and I can also wire it up with dependency injection. Now let me open up some use case like the getToDo_by_ID query handler, and this is a good example of where you might want to introduce caching. So we're fetching an entity from our database based on its identifier, and we can expect that this is a fairly frequent operation. So we want to introduce caching to improve performance. When we cache the result of this database call, we're going to have it in memory where we can continue serving it for a given period of time. We can control this in our setup and also for individual cache operations. And this lets us satisfy this query much faster than if we were to reach out to a database to query for this to-do item. So the core abstraction, as you can see, is the iFusionCache interface, and a good pattern to use inside of our query handler is the cache aside pattern. Now obviously FusionCache supports this, and the method that you want to use is called get or set async. Now it accepts a cache key, and I could use something like to-do and then pass in an interpolated value for the to-do item ID, which I can grab from my query. And then I can define my factory function that gives me access to the cancellation token. Let's also make it async. And what we want to move here is our database call, which fetches the to-do item. So then I can return this. So we want to return our to-do. We also want to pass in the cancellation token as the argument, and we want to use the token provided in our factory function. Let's go ahead and await this, and we're going to be using this to-do item here, which is the response from the get or set async method. So you can see how easy this was to use, and in a minute or two, we've already got caching implemented using the FusionCache abstraction. Now we are injecting this as a service, but how are we going to wire this up with dependency injection? I'm going to do that from the infrastructure layer because I also want to add some external abstractions later. So I'm going to keep this scoped to infrastructure. Now let's call this the add cache method, which currently doesn't exist, but I'm going to define it as an extension method here on the iService collection interface. So we're calling it add cache. It's an extension on the iService collection. And what do you need to define FusionCache? You're going to say services, add FusionCache, and that's it. This is the most basic setup. And now FusionCache will be available as a service to inject within the dependency injection provider, and we can safely inject it into our use cases. The default implementation is going to use the in-memory provider for caching, and this might be sufficient for most applications out there. How about configuring FusionCache? For example, we may want to set things like the cache time, so you can say with options import the missing using statement, and then you have access to the FusionCache options. And this lets you configure so many things that we probably can't cover in this video. Now I want to show you the default entry options. For example, you want to configure what is the default duration for your cache entries. Let's say we want to cache them for 5 minutes. And you can also configure the distributed cache duration, and let's say it's also 5 minutes. There are other extension methods. For example, you can configure the default entry options directly without having to go through the top level options, and this just simplifies your setup to directly access the default entry options. So either of these is fine. I'm just showing you a couple of examples. So let's go back to our use case. I want to place a breakpoint here and a breakpoint in our factory function, and I'm going to start my application. And this will start my application inside of Docker Compose with my API and database running, and I've also got a Seek instance for logging. Now, if I navigate to localhost 5001/Swagger, I can see my Swagger UI, where I can go ahead and quickly create a test user. So let's say test@test.com. Let's set some password. I'll execute this, and you can see this completes. We get a user ID back. I can then use this in the login endpoint minus the first name and last name to get back an access token. So this is what we're going to use to authenticate with our API. So I'll just say authorize, and that's done. And I am going to grab the user ID from the response that we got here. And then let's go ahead and create a to-do item. We're obviously going to need this in order to test out our caching support. So this completes, we get back a to-do item ID. And finally, I can go ahead and send a GET request to fetch this from the database. And this is where we hit our initial breakpoint. Now, because we don't have this cached yet, we're going to execute our factory function, and you can see we hit our second breakpoint. So I'll press continue, and we get a response back in the Swagger UI. So to test this out, I'll send another request, and we immediately hit our first breakpoint. But if I hit continue, you will see that we won't land on the second breakpoint. That's because this value is cached, and FusionCache is going to return the cached value instead of us having to reach out to the database, and this will be much faster. If I jump into the Seek UI for a moment, we can see some logs from FusionCache here, and this is our initial request, where we encounter a cache miss, followed by our database query, and then a log from FusionCache storing the value in the in-memory cache. And then here is our subsequent request, where you can see that we are able to immediately return the value without having to reach out to the database. What about cache invalidation? Let's say I want to invalidate this cache entry whenever I delete this to-do item so that we don't serve any cached value. Well, you can do that very easily. I'll go into the delete to-do command handler. You just inject the FusionCache abstraction, and after I call save changes here, I'll say cache, remove async, and I just need to pass in the same cache key. So this is going to be to-dos, and from the command I can pull in the to-do item ID, pass in the cancellation token, and we've got cache invalidation. Let's say I also want to do this inside of the update to-do command handler. Again, the same game plan, just inject FusionCache, and I can go ahead and reuse the call from my previous implementation and call remove async, and now I've got cache invalidation. Now the problem I have here is having to repeat the cache key in this format, which isn't very refactor friendly. So what you can do is define a simple helper class. I usually call it cache keys, and it looks something like this. It's a static class with either constants or helper methods inside. So I've got a cache key for a to-do item by ID, where you pass in the to-do item ID and you get back a cache key value. How do we use this? Well, I can now replace this with a function call. So I'll say cache keys and then to do by ID, and I just pass in the to do item ID. I can do the same in my command handlers. So now I've got a consistent way to construct my cache keys, and whenever I want to, I can refactor this and it won't break any of my caching code. If I want to, I can even move this into a domain event handler. So let's say I introduce a new class called toDoItemDeleted domain event handler. Because I already have support for this within my code base, I can implement an iDomain event handler interface for the toDoItemDeleted domain event. Let me go ahead and add that. Let's add the implementation, and I'm going to need my FusionCache abstraction, and I can just move the code that I've got here into my domain event handler, make sure that this is async, and then fix any compile errors, and this is also going to function the same. What about distributed caching? Well, we can also do that, inside of FusionCache. So we're going to need a distributed cache to start. The most popular choice is probably Redis, and I'm going to drop in my configuration. I'll use an Alpine image to reduce the image size. We're going to expose it on the default port, and we need to define a connection string inside of our app settings JSON to be able to connect to this. Now the connection string is simple. Because we are running in our Docker network, we can define the service name and the port where it's available, and our .NET application will be able to connect to it. Now we will need a few more libraries to be able to support this, and these I'm going to install in the infrastructure project. So if I look for FusionCache again, there's this serialization library that I want to install, and you want to have this when you've got a two-level cache, like in our example where we are going to introduce Redis. I'm also going to add a backplane, although we don't need it, just to show you what the setup looks like. And we're going to use Stack Exchange Redis. And we want to look for a distributed cache implementation within .NET. And I'm going to install Microsoft Extensions Caching Stack Exchange Redis. And now we've got the libraries that we need, and we have to configure this with FusionCache. So I'm going to need access to the connection string. So what I will do is pass in iConfiguration here, update this to also expose the iConfiguration instance, and I'm going to grab the connection string, which I believe I called Redis. Let me double check that. So yes, that is correct. So now we've got our connection string and the libraries that we need. So let's start with the serializer setup. You just say with serializer, you pass in the new FusionCache system text JSON serializer, and if you ever want to swap this out, for example with Newtonsoft JSON, you can just install the respective library and use that as the serializer for your distributed cache. To configure our distributed cache, we just say with distributed cache. Now we have to provide in an implementation of the iDistributed cache interface, and the simplest option is newing up a new Redis cache instance, and here I'll say new Redis cache options, and we want to provide the configuration value, which is our connection string. What about the backplane? It's very similar. You say with backplane, new Redis backplane. This is available in the library that we just installed. And the same idea, we just pass in the connection string that we can connect to our backplane. And now with no changes to our application code, we have implemented two-level caching backed by FusionCache. To show you that this works, let me start the application, and back in our Swagger UI, I'm going to send a couple of requests with different to-do item IDs to just force them to be cached. Now the first request here is going to execute this and give us back the result, but it's also going to cache it in both the first level cache, which is in memory, and the second level cache, which is inside of Redis. If we take a look at my Docker Compose setup, you can see that Redis is up and running. And if I jump into DataGrip to show you what's inside of Redis, you can see we have 3 cache keys inside, and this is the data that FusionCache stores for your cache entries. So you've got the data property containing your serialized object, and you've also got when this expires. So if we, for example, invalidate this by causing a delete, let me grab the to-do item ID. We can use the to-do item ID from this request here, issue a delete request, and I just placed a breakpoint in the domain event handler just to show you that we're going to trigger it. We're going to call remove async. This will complete our cache invalidation, and if I go ahead and refresh this, you can see that the value is now gone from our Redis instance, and it's also removed from our in-memory cache. And for the end, a cherry on the top, I mentioned at the start of the video that FusionCache is the only production-ready implementation of the hybrid cache abstraction. This is because the default Microsoft abstraction doesn't have a backplane and is going to run into problems when working in a distributed environment. The FusionCache backplane solves this, however, it also comes with a hybrid cache implementation. So what this allows you to do is to replace the iFusionCache interface with hybrid cache if you don't want to depend on non-Microsoft abstractions. So we can use hybrid cache here and just replace the abstraction and just replace FusionCache with hybrid cache, and the calls remain mostly the same. You can see what the cache invalidation looks like. Let's do the same inside of the update handler. I just have to remove the argument name, and the remove async compiles. The get by ID is slightly different. If I replace FusionCache with hybrid cache, the method is called get or create async, but otherwise it's going to look more or less the same, with maybe a different method name here and there and some parameters mismatch. But I think this is a very compelling use case for the FusionCache library, and we've only just scratched the surface here. I covered the basic usages. There are some more advanced options that you can explore, which I'm going to leave for some other video in the future. If you want to see how you could solve the hybrid cache problem and implement cache invalidation in a distributed environment, then I highly recommend taking a look at this video next. If you enjoyed this video, smash that like button so it gets recommended to more .NET developers. Thanks a lot for watching, and until next time, stay awesome.